Welcome back, everyone. I'm Akash Joshi. I'm the OR guru, and today we're going to be talking about the sigma notation, which is commonly used in operations research, and it is necessary for mathematical modeling. And if you don't understand this notation, you are not going to be able to go through operations research right now until you understand it. All right, so basically, the sigma notation is a way to create a summation sequence, and it is used in the compact formulations of many OR problems. All right, so let's start by looking at this problem right here. Okay, so we have an expression right here, 5k minus 2. Our initial term is k equals 1, and our end term is k equals 3. So what this is doing is this is a sigma notation, and a sigma notation signifies summation. Basically, it's gonna add up all of these for when k equals 1 to k equals 3. So it's gonna add up when k equals 1 this term to the term where k equals 2, and then to the term where k equals 3. So I've showed you this right here. So when k equals 1, we have 5 times 1 minus 2. And then when k equals 2, we have 5 times 2 minus 2. And when k equals 3, we have 5 times 3 minus 2. And we are adding all of them up. And if you add them up, you get 22. So this expression right here, this notation, is equivalent to 22. All right, here's another example. If k is squared and we're going from 1 to 4, it would be 1 squared plus 2 squared plus 3 squared plus 4 squared, which would then be 30. So this right here is equivalent to 30. All right, so let's get into a problem now. Let's say we are a shoe factory that sells shoes. There are limited resources in the factory to produce the shoes. Let's say we want to maximize profits. For some reason, my brain read that as a don't. All right, so we're trying to maximize profit. So this is going to be a maximization objective function. This right here is our objective function. It's what we're trying to do because, it's our objective. That's why it's called an objective function, by the way. And we are trying to maximize profits. So how does this equation represent our profits? Well, we're assuming that we sell 3 different types of shoes. That's part of the problem. We sell 3 different types of shoes at a profit of $55 for shoe 1, $70 for shoe 2, and $110 for shoe 3. So this is shoe 1, x1, this is shoe 2, x2, and this is shoe 3, x3. These x variables represent the number of shoes that we sell. So if we sell 2 shoes of x1, we'll get $110. If we sell 3 shoes of x2, we'll get $210, just 70 times 3, and so on. So the x variables represent how many of each type of shoe that we sell. All right, so if we don't have 3 types of shoes and we have varying profits, because this would depend on each of the factories, each of the brands of shoes, it would depend on everything. We're probably not going to be producing 3 different types of shoes. Maybe one year we'll produce 7 types of shoes, the next year we'll produce like 15 types of shoes. It depends. So what is a general formulation for this problem? This is our compact formulation, which is our general formulation. And if you notice, it utilizes the sigma notation, which represents summation. So what does this mean? All right, so first we have the number of each shoe that we sell. XS would be like X1, X2, X3, the first shoe, the second shoe, and the third type of shoe. And PS is the profit for each of the shoes. So the P1 would be the profit for shoe 1, P2 would be the profit for shoe 2, and P3 would be the profit for shoe 3. So we are going to multiply these together, and then we're going to add them up for however many number of shoes that we have. This N represents however many shoes that we produce. If we produce 10 shoes, then we'll add up the profits times however many shoes we sell of each type, and that will be what we are trying to maximize. And of course, we start with shoe 1 because that's just the number you start with. All right, so hopefully you understand this right here. If not, please pause and go back and listen to what I was talking about, or just check out another video. Okay, so let's say there are 3 resource constraints. There are 100 pounds of rubber, 80 pounds of plastic, and 50 pounds of leather. These are all the ingredients that you use for the shoe. All right, so shoe 1 requires 0.5 pounds of rubber, 0.7 pounds of plastic, and 0.1 pounds of leather. Shoe 2 requires 0.4 pounds of rubber, 0.1 pounds of plastic, and 0.2 pounds of leather. Shoe 3 requires 1 pound of rubber, 0.1 pound of plastic, and 1 pound of leather. So how are we going to represent these as mathematical constraints? All right, let's see. So here are our resource constraints. We have 100 pounds of rubber, 80 pounds of plastic, and 50 pounds of leather. This is our leather constraint, this is our plastic constraint, and this is our rubber constraint. So for our rubber constraint, if you notice, shoe 1 requires half a pound of rubber, shoe 2 requires 0.4 pounds of rubber, and shoe 3 requires a whole pound of rubber. So the coefficients are what we are multiplying by. Because if we produce 2 shoes of shoe 1, we are going to use 1 pound of rubber total. Now, if you add all of these up together, it should be less than or equal to 100 because 100 is the only amount of rubber we have. So that is what I have done for all of these resource constraints. If you don't understand, let me explain it one more time. Let's look at leather now. So there are 50 pounds of leather. We can't use more than 50 pounds of leather. Shoe 1 requires 0.1 pounds of leather, shoe 2 requires 0.2 pounds of leather, and shoe 3 requires 1 pound of leather. So if we produce if we produce 5 pairs of shoe 1, then we're going to use a whole half a pound of leather because 5 times 0.1 is 0.5, 0.5 is a half. So basically, however many combinations of X1, X2, and X3, however many types of shoes we sell, and we multiply it according to how much how many pounds of leather each type of shoe uses. Once we add all of them up, it should be less than or equal to 50 because 50 is the only amount we have. Okay, so now that we have this, how are we going to represent this as a compact formulation? How are we going to generalize this? Because I'm sure in your shoes, it's not just rubber, plastic, and leather. There might be less materials, there might be more materials. It depends. So if we're a different factory and we have multiple materials, or if we're another factory and we only have one material for your shoe, how are we going to generalize this so that this formulation can apply everywhere? All right, so here is our compact formulation right here. First, let's define WSR. WSR represents the pounds, the weight of resource S required to produce shoe S. Sorry, this should be resource R. Let me just change that really quickly. Yeah, so WSR represents the pounds of resource R required to produce shoe S. So resource R is the number of resources that you have. R1 is the first resource, R2 is the second resource, in this case it would be plastic, and R3 is the third resource, in this case it would be leather. So yeah, so those are let me repeat that one more time in a different way. WSR is simply the weight of each shoe. No, WSR is simply the weight of the resource required to produce a certain type of shoe. All right, so we are going to multiply that weight by the number of shoes of that particular type that we sell, and we're going to add it all up for all of the different types of shoes we have, and that combined should be less than or equal to the amount of the resource we have. All right, I hope you can understand how this compact formulation using sigma notation and summation represents this over here. Of course, we will need to input some numbers in. The computer cannot just understand these letters right here. It cannot understand that these letters represent these numbers. We have to clarify what each of these mean. But generally, this is the formulation that you can use to solve any different type of problem. You can simply input this into the computer and define all of the different terms. So you can define all of these variables. You can define all of these different types of weight. And yeah, okay, that's it for today. Thank you for watching. Goodbye.